recap of what we did the last couple of days. On the last couple of days, we were trying to find the missing value, find the value of the variable. And in a few days from now, we're going to do that again. But we're going to have harder problems to solve. Instead of 1 steps and 2 steps, we're going to have multi-steps. And the part of the multi-step is where you have to combine like terms to get to a 1-step or a 2-step. So today and tomorrow, we're just practicing combining like terms. And I want you to look at, one more time, look at the sets of examples, because we're going to see different sets of directions in your homework, combine like terms, and simplify each expression. And really, they pretty much mean the same thing. But there's no solve at all, because there's no equal sign. So we're just putting things together that are like terms. So does anybody know what a like term is? You might have done a little bit of like terms last year. Like maybe the very first thing I should do is talk about, before we get to those notes, what like terms are. So let's just add in a blank page. Like terms are things that variables usually. Ingrid, the folder's right here. So examples, a good way to do this is look at examples and non-examples. So if we think in pairs, an example of like terms would be 5x and 4x, because they both have x's. Something that would be a non-example of like terms would be 5x and 2, because 2 doesn't have an x. Okay? Adam.
Would 5x and 5y be a like term?
Good example. That's a non-example. Good question. So 5x and 5y are non-examples because the variables have to be the same. Okay. And you're going to see, as we do more algebra, much more complicated examples and non-examples. We'll stay with some basics today. 2 and -5 are like terms. You already do that all the time. So if you have like terms, you can add them. You know, so under this I could say, so since they're like terms, 2 plus -5, I can combine those to be -3. Since these are like terms, the 5x and the 4x, I could, oops, because they're both numbers, so they can be combined. Whereas so on 5x and 4x, I could say, since these are like terms, I could ask you to combine them. I could say 5x plus 4x, and you would combine them to say, well, that's equal to 9x. The other reason I had parentheses is I was tying that into the problem above. But if I asked you over here what 5x plus 5y was, you would say it's equal to 5x plus 5y. You can't combine them.
So you can't say 10.
No. So if they're not like terms, you can't combine them. That's the general idea. You can't say 10xy. That would be wrong. And when we're talking about like terms, you can only add and subtract like terms. It's different for multiplying. We already practiced multiplying earlier this year. So the key here is when adding and subtracting, which is what we're going to focus on today. You can only combine what we call like terms. And this is for adding and subtracting. Adam.
And without variables, a like term?
Right, so anything without variables would be a like term. 1 and 3,000, they're like terms. Negative 1/5 and 2/3 are like terms. So if we looked at another example, make a little room here. Another set of like terms would be like 2/5 and 6 squared. Those are like terms because they're both numbers. Even though they look different, if they're just numbers, they're like terms. Because you could figure out 6 squared is 36. So you could add them. Okay. So let's see how I rearrange my pages here. Let's look at keep the like terms on the right while we talk about the problems on the left. So your directions today in your homework, the blinking pen there, is to combine like terms. It's sometimes so easy it can be confusing. I want you guys to close the book up and listen and take notes today. Close it up. So this starts out really easy. Gets a little harder. I'm just going to show you a couple techniques as it gets harder that have been really successful for kids. So the first one really ties right into what we did over here. It's just a simple example like 5x plus 4x. Since they both have p's, they're like terms, so we're just going to add them. So 8 and 13 make 21. So there's not a lot to that. That's the whole problem. But it's important to understand the basics before you get to the harder ones. Okay? So when you look at the second example, for most people, when you begin algebra, it's helpful to think of that as a 1 cube. So 1 cube take away 9 cubed. Yeah, it'd be negative though, right? Because you're taking 1, it's like 1 take away 8, so it's just a negative 8 cubed. Okay, so so that's not very interesting, but it's important you can do those. So here's where it gets a little bit harder. And actually, we're going to put a fourth example in here that's even harder. But first, you just want to always think, so this is not so hard because they're all additions. It gets harder when you throw subtractions in. Matt, you want to do this?
Yeah.
Okay.
So, is it 3h?
Right, because you're going to think of this as a 1, right? So you have your 2h here, and then you're really adding the 1h. So you have your 1h there, so that gives you a 3h.
3h plus 7r.
Right, because you're adding your 4r, a positive 4r, and a positive 3r. So you get 7r, and it's positive, so think of it as a plus 7r.
Plus 8t.
Yeah, plus 8t. So that's good, and that's not too hard. So here's how it gets a little harder. When you have subtracts in there, it becomes more confusing. There'll be subtracts all over the homework. Okay, so let's put one more example. If I did like 5h plus 6t minus 7h plus r minus 4t and plus 5r. Okay, what do you have, Noah?
We'll do the so you do 10t. So you would add the
No. You're gonna add the t's, so before you guys, before you do that, there's some techniques that can help you avoid those mistakes. Let's try one more person. Sean?
Would you do negative 2h?
There would be a negative 2h. So you would have a negative 2h. I'm gonna write that down.
Right.
Adam?
And then you do plus 2t
You would have a plus 2t.
plus 6r.
And you would have a plus 6r. Okay, so for those of you that don't understand that, what works really well is to kind of think of the operation, meaning add and subtract, as a negative and a positive. So you could take your 5h, that's positive, and you're going to subtract 7h.
So basically like make separate problems.
So you make separate problems, right? So between those two, these two give you the negative 2h. And then you could take your positive 6t and your negative 4t. And that's just a 2t. So or you could think of it as a 6 take away 4. So that gives you a plus 2t. So now you think of it as a positive 2t, so you make it an add 2. See what I'm doing there? And then you've got your positive r here, and another positive 5r, so it's 6 r's, and they're positive, so you think of it as an add 6r.
So if you would have a negative 2h there, it would be like a minus.
Yes, and even one more step, almost always, and you should just do this as a habit, you would write your final answer alphabetical. So,
HRT.
right, you'd have negative 2h plus 6r plus 2t. That's your final answer. Natalie.
I have a question. How do you say whether to do a plus sign or minus sign when you're done with the when you're simplifying?
Okay, so when you take, the question is, how do I know down here if I have a plus or a minus? Just think positives and negatives here if you can, or 5h take away 7h, but you get a negative 2h there, right? So that becomes a minus sign or a negative. So it was a negative 2h because I put it in front, but if it wasn't in front, it would be a minus. And we're going to practice a little bit more. Okay, so let's go to these other examples and use the distributive property. It's a East 7 day. What time do we get out? Oh, we're doing fine. Okay, so here's where the warm-up ties in, that you have to use the distributive property. So your first step would be, you're going to copy the 7t down, but then you're going to distribute. So you have a subtract 2t. Okay. And then you've got to think of this 2. So you have to get used to thinking of a subtract as a subtract or a negative, depending on the situation. When I'm multiplying in further, I'm subtracting a negative 6, or you can think of this as a negative 2 times a negative 3, which is how I do it. I think it's easier, because when I multiply a negative times a negative, I get positive, so I just think of this as an add 6. So first step would be use the distributive property, and then the second step is combine the like terms. So it's an easier combining here, but the distributive property made it a harder problem. So those are like terms. So 7t, take away 2t, so that's just what? So it's just 5t plus 6. And so if you look over at our list here, right, that would be kind of like this example. We have a variable term and a constant term. We can't combine them. So our final answer is 5t plus 6. They're not like terms, so we leave it alone. Okay. Can you guys, let's have you try, let's see, let's have you try both of these here. So use the distributive property, then combine like terms. Write them down, let's try 'em. Does anybody have the first one done? Who haven't heard from today? I don't think I have from you, Skylar.
So first I did the distributive property with the 6.
Okay, so then you brought the 1 down? Okay, and distributive gives you?
6 minus 6b.
Minus 6b.
And then plus 54.
Plus 54. Okay. So then you have your terms that are alike are these two. So what'd you get with those?
I thought you would do, I thought you'd add them.
You do, because of the operation in front of 54 is an add.
So you do 55.
55 minus 6b. And that's your final answer. Raise your hand if you got that.
No.
Okay, raise your hand if you understand it. What were your mistakes, you guys, or did you not finish it? Did you had a mistake? What was it? Try the next one.
I did 6b plus 64, and I subtracted 1. I had 6b plus 50.
That's common because of this subtract here, right? But you always want the operation in front of the term to go with the term. So to combine the 54, you're going to take the operation in front, so you're going to take the add. 1 plus 54. Okay. Lexi?
I don't understand how you got 6b plus 54.
Because this is a negative. Think of this as a negative times a negative.
Oh, okay.
So even though it's a subtract, it behaves like a negative. So it's just contextual. So sometimes you think subtract, but when you're doing distributive property, you're doing multiply. So then it's negative times a negative. Let's let everybody finish this last one. Go. On the next one. It's 55 take away 60. Okay, Vanessa. Yeah, for the next one. What'd you do?
4d
4b
minus 12
minus 12. Good.
plus 2b.
Plus 2b.
And then
No. So here's the technique I want you guys to focus on tonight. Group, before you do the next step, it's the most tricky part. Think of what's in front of the 2b. It's an add. Don't think of what's after the 4b. So it's 4b plus 2b. Does that make sense, Vanessa?
Yeah.
So it becomes 6b minus 12. And that's your final answer.
Wouldn't it be plus?
Say that again?
Wouldn't it be plus?
No, because in front of the 12 is a minus, so that has to stay with it. The operation stays, the operation in front of the number stays with the number. So like in front of the 2b, you have a plus, so you have 4b plus 2b. But then the subtract here stays with the 12. Okay? So if you guys look at my notes, I circle and use color to get that operation with the right number. That's the hardest part about this, is keeping the operations with the right number.
Do you draw a line with it too big? You have to do whatever?
Yeah, you can. You know, I've worked with kids doing this a long time, and this technique of boxing everything really helps people. You know, like on your paper, you could either box and circle, you know, so like I use boxes and circles here, boxes for like terms and circles for the other like terms, or colors, yellow and red, you know, over here when we did this one. right here, I put the like terms in matching colors. Adam,
On the first one, I don't understand where you added 1 and 50.
because they're like terms. They're both numbers.
Oh, there's the minus.
Yeah. So I'm just gonna make a new page. The question is 1 minus 6b plus 54. So what I'm saying is you take the operation in front of the number.
Where'd you get the plus though? Wasn't it? No,
Oh, because this is like over here, this is a negative times a negative. A negative times a negative makes a positive. So that becomes a plus 54. So this we are going to add to get 55, and then we have a take away 6b. So if I just did one more example kind of like that, if I had like 3 take away and a 4 here, and then x plus 12, this would be 3, and the distributive property would be minus 4x. But now we have a negative times a positive, so this becomes a negative 48. Does that make sense so far? You see what I did? This is
I got that.
okay, and then I'm going to get my like terms, so now I'm going to do 3 take away 48. So I'm going to get a negative 45. And then I still have this term, so I just say subtract 4x. That's my final answer. Okay. So let me stop this and pass out your quizzes.